Hello, and I would like to thank you for tuning into this recorded virtual lunch and learn that was presented by the Osborne Company in conjunction with Caleffi. The topic of this presentation is balancing hot water recirculation systems with a thermostatic style valve. The presenter is Max Rohr. He is the Caleffi Education and Industry Engagement Manager. He has over 20 years of experience in the industry. So please give us a thumbs up and subscribe if you find the training to be valuable. I will now let Max Rohr start with the training.
Sounds good. So today is kind of a part two to DHW Recirc. If you didn't catch the first half, that's fine. I'll kind of do a slide to bring everybody up to speed if you're new this week. But what we had talked about in the past is mixing, what are we doing to set ourselves up for success in the mechanical room for a hot water recirc system. So now what we're going to do is kind of take it further into the building. And one of the things I'll mention off the top is a couple other topics, a couple other resources related to this topic. This Hydronics Trade Journal is a free trade journal that we have. You can get these shipped to your house, or you can go to hydronics.caleffi.com and see kind of an interactive version where we add videos and things like that. These are great resources on the topic. So just basic domestic water heating. And then issue 22 is mostly on the mixing valves, and 21 is kind of the topic that I'll cover today on balancing valves. And then another one is Coffee with Caleffi. This optimizing mixing valves in a DHW system was a good webinar that we did last year. And actually this month, just the last Thursday of the month, we're going to do a deeper kind of dive on the electronic mixing valves with Coffee with Caleffi. So sign up for that one as well. Then one of the things that I like to mention is we do have BIM files that they're modeled in Revit, so they're light, they're not going to crash your computer when you open them up. And then they do have some calculations built into them as well. So I know that that's not always used to figure out your delta T or something like that, but we're just trying to kind of stay ahead of the game a little bit with our Revit files that are available on BIM Object or on our website. And then we're also in master spec if that's something that's useful to you. We've got all of our products there specific to North America. We've got international products on there too. But okay, so today we're going to talk about DHW Recirc. We're going to go over a little bit of the review of what's happening in the mechanical room. We'll talk about the different styles of balancing valves, how you can, all of these valves will end up doing the same thing. And we've had some long conversations with engineers that you can balance a building based on flow, or you can balance it based on temperature. And really, if you do it well, the occupant won't know, and you're going to save water and save energy in the process. It's just kind of a few different ways to do the same task. And then I'll talk about how this can be used for thermal disinfection. And we'll talk about a couple projects. This slide I wanted to mention, and I think I've got these same pictures elsewhere, specific to the California market. There are some cases where you do need the ability to verify pressure upstream and downstream of a balancing device. So we have a few different options in the catalog to do that. Also with the ball valves that are with the stem extensions to go up and over insulation, because I know that that's a big part of system design in California, is to have enough insulation for the energy codes and things like that. So to start with, I'll kind of recap. So this was a series of products. So we talked last week about the LegioMix electronic mixing valve as kind of the heart of the system. That's going to send the hot water out into the building at the temperature that we want, or to elevate it for thermal disinfection, which I'll talk about at the end of the presentation. And then the balancing valves we'll cover today, and then point of use mixing valves. So those three products helped us win one of three finalists for the AHR Innovation Award in the sustainability category, which was kind of cool. So that specific to California, where you're trying to balance energy use as well as water waste, because water's such a valuable commodity there, versus Michigan or something like that, where they don't really care if the wait time to a tap is a little bit longer, as long as the code allows that, because the water's just not something that's as scarce for them. So this is kind of the best way to balance the energy efficiency of the equipment, so we're not heating water to just dissipate recirc energy that's unneeded into the space. And then also make sure that there's a short wait time at all the fixtures to get the hot water that we need. Okay, so This is just kind of an example riser in a commercial building. We've got a balancing valve on the return of the hot water recirc loop. And we can do this with really any of the balancing valves on the page here. So there are a couple other competitors that have been around and are kind of generic names. So people will ask us if we have a circuit setter. So that's the B&G trade name. We do. This flow set valve is kind of the same performance manual balancing valve. And then everything in between, we also have a kind of a fixed Venturi valve that I'll talk about a little bit longer. And then a newer one on the market is the circuit solver. So this is going to be a thermal balancing valve, and we'll go into a lot more detail about that. It's kind of a different way to approach the same topic. But basically what we're trying to do is just make sure that there is equal opportunity to get hot water at each of the fixtures throughout the building, because water is going to take the laziest way back to the mechanical room, and it might just be straight up riser one and back to the mechanical room, and the rest of the building could be waiting a really long time to get hot water, which we don't want.
Hey, Max,
Yeah.
just because it's on this picture and it's a newer thing, you want to point out the plumb vent?
Yes, so the plumb vent is right here. So we have a this is a listed for hot water use, for potable water use, air vent. And it's something that this is kind of the right application for it. You'd put it right at the top of a riser stack like that, and it would vent any air that has accumulated right at the top there. In problem job sites where you have pockets of air at the top fixture coming into a sink, that you always have a little bit of air spurting there. If buildings sit for a long time, that can be another thing that it's nice to have a little air vent to purge that out. So that's kind of a newer thing for us. I think that we're the only ones on the market with potable water rated air vents to use in a recirc system like this. There's one other competitor that has a stainless steel version, but it's more of a central location, more for like probably aggressive fluids in a hydronic system type application. So that can be a problem solver for you. And that's where it would go, right at the top of a riser there to get the air out. Okay, so then the next category of balancing valves that I'll spend probably the most time on is a thermal balancing valve. So a lot of these, I guess all of these, except for the circuit solver, are going to modulate your riser based on flow. And some of them are going to be just an orifice that you set with a chart. But the thermosetter that I'll spend more time on is a thermal balancing valve. So it's actually adjusting based on temperature. And I think that one of the titles that we've used for this presentation in the past is it's a temperature solution to a temperature problem. So we want to make sure that this, all of these fixtures can see whatever our temperature is. If it's 110 degrees or 120 degrees, we can figure that out, theoretically, and use any of the flow-based balancing valves. But really what we want to do is make sure that the temperature is correct. And the thermal balancing valves can be a nice way to do that automatically without the need of additional balancing or specific charts and things. So historically, a manual balancing valve is what you're going to see in the field most of the time. This is what we've used for hydronics applications and for plumbing balancing for forever. These are kind of the original balancing valves. And B&G's done a really good job of kind of paving the way for that type of product in the past. So you'll see many, many, many competitors in this world for a balancing valve, a manual balancing valve. It's going to be the lowest cost. So sometimes in a value engineering scenario, we've spec'd a different balancing valve, and then the engineer comes back and they say, okay, we're VEing down to the circuit setter level of balancing valves. And that's how it goes. Sometimes you can still make this work, but I think that the argument that I'll try and make over the course of the presentation is that's going to be the lowest purchase price for a balancing valve to put on each of your 8 risers or whatever. It's not going to be the least expensive installed cost. And I live in Utah, and it's not nearly as bad as it is in California, but it depends on what your labor rate is. It depends on how much a balancing contractor charges per hour to balance those 8 valves. There are some cases that the installed overall total cost of a manual balancing valve is going to be a lot more expensive than it would have been to go with a valve that's going to essentially balance itself and not need that additional valve by valve balancing and rebalancing in some cases. So with these valves, the flow varies with pressure changes. So with an old fixed speed pump, it's the most difficult way to do it, still again possible, but you've got a fixed speed pump that is going to have a curve, and as the flow rate changes, so does the pressure at each of these valves. So the flow is going to change every single time that you adjust one of the valves. You'd have to redo all of the other valves, or if you added a zone or something like that, each valve is going to move in that scenario. So if the maintenance person comes and turns that knob half a turn, you really would have to kind of start over to rebalance that whole building to make sure you're where you're supposed to be based on the plans or things like that. And if you're troubleshooting and you're just trying to adjust it, by feel, because that riser is cold or something like that, it's really the hardest to get back to square one without redoing the whole building. So what you need is a manometer to do that. So you've got an upstream and a downstream reading. I'll kind of show you where those would be on these different styles of valves. So there are some that are a variable orifice style. So this would be like the B&G circuit setter or our flow set valve that's in the Caleffi catalog. So in this case, you've got a pressure port upstream and downstream of an orifice that you can, you use the adjustment knob and you adjust that up and down. So it changes the flow in between these two pressure ports. And then the other style is a fixed orifice, a Venturi style. So in this case, you have the upstream and downstream pressure port on the Venturi here. So nothing changes in between those ports. You're just going to use this almost like a globe valve style adjustment knob that's downstream of that to make the adjustment. So really kind of a nuanced thing, but the variable orifice has the orifice in between the pressure ports, and the fixed has it kind of after you've gone through the Venturi and done your reading. So the third style of manual balancing valve that's in our catalog and is one of my favorite products for both hydronics and domestic hot water. This one is the Quicksetter Plus, is listed for DHW applications. It is essentially just a manual balancing valve, and it's like the variable orifice. Well, I guess it's more like the fixed orifice. So you've got your Venturi right here, and then you've got your manometer reading your two pressure ports upstream and downstream of the Venturi, but it's just built into the valve. So you pull this little pin right here and water bypasses along this red line through the flow meter. And then you can use a wrench to adjust that down to the flow rate that you want. You pull the pin, a little ball that is going to be in that window that doesn't cloud. That's a separate chamber right here, a little magnetic ball. It's going to move as this flow meter. The red part is a magnet. We'll kind of slide that ball up and down. You can see that, I was supposed to be at 1 GPM and I'm at 0.75 GPM. And you can open up that ball valve a little bit more. Then you release the pin, and now the water does not flow through your manometer anymore. So when you release that pin, this closes the orifice here, and then water just goes straight through the valve. So the reason that that's important is because you don't really want all the system debris and any of the minerals that are accumulating in scale and things like that to go through your measurement device 24/7. You just want to use that to check, and then you release it, and that keeps it from getting gummed up with a bunch of system debris. So you could there are many inline flow meters that are just a clear window with a flow meter that moves up and down there, but that's going to be susceptible to the water quality of the system, and those can cloud, or those can get gummed up eventually, or have something holding them up. So the 99.9% of the life of this valve, water is just going straight through it unless you manually pull the pin and let the water go through the flow meter there. So you're taking the tool out of the balancing there. This is something that's really helpful for commissioning engineers that you want to go to the job site and without having to have the balancing contractor walk around with you and prove that they did the balancing right. At any time, any day, you could walk up to that set of balancing valves if they're on the same place, or hop on a ladder and pull the pin and see if it is still where it was supposed to be. Really good for mechanical contractors and troubleshooting scenarios too, where you just don't know if there is flow in a certain part of a building that maybe you're taking over the service of, and you just don't know if there's any flow to that part of the building right now. There's, something you're trying to work out with the pumps. You pull the pin and say, okay, we have 0 GPM right here. What's the problem? Why would that be the case? Or you pull it and say, oh, this is supposed to be 1 GPM and it's 4, or something along those lines. Keeps you from having to get the manometer out to do all those readings. Again, it's the exact same function as another manual balancing valve. You just don't have the tools built into the device itself.
Max, before we start on the next one, someone had a really good question come in, and I know I'm going to steal your thunder because they are asking about something I know you'll talk about. Okay. But they were in a hospital application. If facility is disinfecting the system by circulating 160-degree F water, will there be any issues with the thermal balancing valves? And I'll just simply say that there's a bypass, and you'll talk about it with the thermosetter. I just wanted to, get that question out there. I can't imagine you weren't going to talk about that. So
no, but I will go back to that because there are a couple different choices you can make with the thermal balancing valve. The standard kind of compact thermal balancing valve would be your worst enemy in that scenario, because it's trying desperately to close. If it sees 160-degree water, it's saying, we're good, that's too hot, close it back down. But we have 2 other options that are ready for that say, okay, the actual main chamber of the thermal balancing valve is going to close as much as it can. But then there's a bypass that says, okay, 160-degree waters for thermal disinfection. Let's let that through, because that's what we're trying to do right now. But it's kind of 2 different chambers to do that. Otherwise, a standard thermal balancing valve would actively try not to let you do thermal disinfection. But that's a good question.
Sorry, since you're still on that slide, if you scroll back,
go back one.
Another one was asking, do you need to hold the pin while you're adjusting the pressure? So on that one, you're not necessarily adjusting the pressure, you're just turning that dial up on the top, and you're moving that ball valve left, open or close. So you can hold the pin out, but if it's hard to hold the pin and adjust it, it really isn't. I can do it. So you can pull the pin and turn it at the same time, but you can let go of the pin, make a small adjustment, pull the pin again, make a small adjustment. So
and it's important to point out, Brian, we're adjusting flow, and then the other ones we're reading pressure, but we're still trying to adjust for flow.
So it really is the flow you're looking at. So it's not changing anything external other than turning that ball.
And one of the things I forgot to mention is that manual balancing valves are a great pair for an ECM recirc pump, because one of the things that's tricky about a fixed speed pump with a manual balancing valve is that curve, where basically with an ECM pump, you could say, I want to flatline it at X pressure and in feet ahead or PSI or whatever. So that does make all of the balancing with these manual balancing valves easier if you can flatline the maximum pressure that you want, because the flow rate may change, but the pressure is going to be more fixed, which is definitely a big helpful way to commission these systems, and won't make it so wild to make changes to a manual balancing valve based on the flow rate, if we can kind of keep the pressure part consistent. Okay, so the next type of balancing valve that I'll talk about, and I think that this has been a great kind of fit in the California market as well, would be an automatic pressure independent fixed GPM balancing valve. So the way that this valve works is that as water comes through it at higher pressures, it's just going to compress a spring, and this little cartridge slides back and forth based on the pressure. And as the pressure increases, it's going to push that little shuttle, and it's going to close more of this like a kind of half of an hourglass orifice down. So if it's low pressure under, I'll come over to this chart in a second, but if it's under 2 psi, it's just going to be wide open, and it's going to let water go through that entire Y-shaped orifice and the little pinhole there. If for some reason, and maybe it's because the pump size is wrong, you're at like 32 psi across this valve, which would be bad. There's something else that needs to be addressed there. It's pushed this spring all the way down, so there's just this little pinhole that water is going to flow through. So it doesn't close completely, but it's going to modulate basically the orifice with the pressure. So if we look at the chart on the right here, in this example with one of these valves that under 2 psi, the flow rate is going to be up to, we'll say that it's 2 GPM. And then when we get to that 2 PSI that we've developed, it's going to just flatline that flow rate to, 2 GPM all the way up until it's above 32 PSI. So this really is helpful. You could just, assuming that you're in the ballpark with your pump size, it's going to give you that exact flow rate that's on the sticker on the cartridge at every riser you put it in. So this also came from hydronics applications where you would just put one in and say that is a 2 GPM fan coil, that's a 3 GPM fan coil, that's a 1 GPM fan coil, and not have to balance anything else. You just put that in, make sure that the arrow is pointed in the right direction, and then you're kind of done. So it automatically balances itself. As the delta pressure can be up or down, and it's just going to keep you right in that specified flow rate all the time. So really easy to install. This is one thing that the Osborne team has been really kind of instrumental in, is they're like, this is just the best thing that you could put into a recirc system, even in a smaller system like a multifamily with 4 units or something like that. We have PEX A barbs, we have crimp PEX as well. But in this application, let's say you've got a 3/4 inch PEX return line coming back for the whole building. You put this in on the return before it gets back to the recirc pump, before it gets back to the mechanical room, and you set your speed limit to whatever your piping material is okay with. And off the top of my head, and I don't remember them as well, but if it's a 1 inch pipe is 2 GPM, if it's PEX or copper or CPVC or whatever you're using, you find the speed limit that pipe manufacturer says for hot chlorinated water is worst case scenario, and you say do not exceed 1 GPM on 3/4 inch pipe, or whatever the numbers line up to be, and that valve is just going to modulate up and down. You could completely quadruple your pump size within reason, and it's going to say we're not letting more than 1 GPM through that loop, because it's the completely missized recirc pumps with that hot chlorinated water that are going to be hard on piping materials. And it's not a PEX issue, it's not a copper issue, it's not a plumbing pipe material issue, it's just it's a velocity issue at some point. So this is really the governor for the speed on the golf cart, to make sure people don't do crazy things on the golf course or something like that. And then it has the stem extension that you can get up over the big insulation that you would use per coat out there. So this is a great way to protect your piping material and really protect yourself from the maintenance person at a hotel or something like that saying, hey, I don't think this recirc pump is doing enough. I found one that's 4 times as big and we're going to put that in. This valve is just going to hold that max GPM, and that's something that's really important for recirc systems and just the longevity of piping materials, regardless of what that is. And I don't know if you guys at Osborne want to weigh in about that.
Yeah. So what it is on hot water recirc, we are listed. We manufacturers as a manufacturer's rep Uponor, and so they are listed for 24/7 continuous recirc. And the issue is, and people kind of gloss over it in the design manual, and we try to explain it to them, make sure that they see it, is that listing only holds true when you maintain less than 2 feet per second in the piping. So you would just calculate whatever the velocity is, to maintain that on the GPM rate, and then put the cartridge in. And then that way, if there was ever a warranty issue with the recirc return line, you can prove to them that you've maintained less than that flow. That tends to be the largest issue right now, is people not controlling that flow. And then the pumps, like you said, are oversized. The engineers are going to add a factor, and then the plumber may add a factor, and you just end up with a superly oversized pump. One person asked a question, and I'll see how you weigh in on this. How much difference does flow balancing make when the return lines are generally sized without checking often at 3/4 inch pipe, when the main feeding fixtures could be much larger? I have a response to that. Do you see what he's trying to get with that?
Yeah, go ahead. You want to start there, and then
So what I'm thinking you're talking about is, well, if I have these 4-inch mains, but I only have a 3/4 inch return line. Do I really want to balance this? And the thing is, you got to remember in hot water recirc, the only thing you're balancing is the heat loss to the furthest fixture. So you just do a calculation for the heat loss, and it's not that big. A lot of people think it's way more flow than it usually actually ends up being. So you could have a really big, well-insulated main distribution line at 4 inches. Let's say, I don't think it'll go much bigger than that and still have a 3/4 inch line. But your 3/4 inch line, even maintaining the proper flows for the piping material, probably would handle a very well insulated 4-inch main. So you will have that, but you would still want to balance it, because the issue is if you don't balance it, that 3/4 inch line is way more impacted by an increase in flow. You're going to get way faster velocity. So that would be my thing. It's like, even if it's all tying back into just a single 3/4 line, you don't have a bunch of branches to maintain the piping and save yourself. I would still balance even a single return line back, just to maintain it. One other thing on this, before we go off of it, say I engineer a building, and then the way it's designed versus the way it's actually plumbed is not always the same, just because of limitations and restrictions. So if I were to order this with like a 1/2 GPM cartridge, and then my line is not maintaining heat on that line, and I'm like, okay, I need to bump it up, I need more flow. How much of this do I have to actually replace to increase the flow of that cartridge?
So the bodies are going to be, as long as the pipe sizing wasn't wrong or something like that, you could just break these unions, and then you put in a new cartridge and then update the sticker. So we would say, if you called us and said, hey, we actually need 1 GPM cartridges in these valves, we would send you the 1 GPM cartridges and then a new sticker that you put on the outside of it. And I'll show you an easier way to do that too. We've got a different valve body style that's new to the catalog, that you could drop a new cartridge in, but you're basically just sliding in that cartridge. There's no other.
So all they have, as long as the pipe size is the same, or the reduced size doesn't affect anything, they really only need to replace the plastic part. And if the device needed service in the future because it dunked up, you're literally just replacing the plastic, not the metal.
Yeah, and then I don't know if I've got that. I might have to jump back a couple slides to show.
Oh, you're talking the Y version?
Yeah, I don't think I put it on this slide. So we also have this version that's going to be the same automatic balancing valve, but you can pull the cartridge out here without having to crack the unions and take the whole valve body apart, and then also clean it out. So it's just a little bit easier to service. And if you did have to change the cartridge, you're just doing it through the Y. And then one of the things that we talked about before the webinar is that in some jurisdictions, you have to, for the balancing report, have a different balancing contractor come in and say, here's the pressure upstream and downstream, and here's my balancing report. You would find, again, in that like 99.9% of the times, that is, if the pump's sized right, it's going to be exactly what that cartridge is set to, if you look at that through the chart. But in some jurisdictions, you have to be able to test it, where this is not testable. This is, will work the same and is going to flatline that GPM, but you'd have to put in your own upstream and downstream pressure ports, Pete's plugs to do that, where we built all that into a kind of a Y body style too, that you could still get with the ball valves. I think isolation might be required by code in some spots out there too. And then the stem extensions. So
yeah, we like the isolation valves because we view it as a serviceable component.
It is. Yeah.
You don't want to have to drain an entire hot water loop just to service your balancing valve.
No. And then another thing that you mentioned a second ago too, that so if you're using PEX, and specifically the Uponor PEX that Osborne is the rep for, so there are different categories of like chlorine exposure essentially.
Yeah.
And what the Uponor is a category 5, which means you can do 24-hour a day recirc of up to 140 degrees, and like you mentioned, that 2 feet per second. Where other categories of pipe, like category 3, is going to be 140 degrees for half of the day. So that's a little bit, harder to calculate, still achievable, but that's kind of what we're talking about with that constant high temperature recirc. If you were going to do, thermal disinfection, you said, you know what, we're just going to do 160 degrees 24/7 for the rest of the life of this building, that is still, excessive, and you wouldn't want to do that. And I'll kind of cover how you could do that better with the next style of balancing valves. But yeah, that the category of pipe, you could use a cartridge and figure out the math. That we don't want 140 degrees all the time. If it were a different piping material, we want X, and find the right cartridge for that. And again, the Osborne guys will help you size the recirc pump perfectly for whatever you're doing. This is almost like a safety factor to say that no one can go in and change the program of this pump or put in a bigger pump and ruin what we spent all this time doing. It's like just the kind of insurance policy that the velocity is not going to exceed what the pipe is designed to handle. Where just relying on the pump, you could have a change in the future that could throw that off, which we don't want. So I saw a question. Are you saying max velocity
so
2 feet per second? So this is kind of a tricky one, because for PEX, like 2 to 3, you look at what the manufacturer says. But the interesting thing is, for copper, they've said 5 for a long time, up until that 140 number. So even the copper development index or handbook says 2 to 3 feet per second if you're above 140. So that rule of thumb of sorts is different if you're doing high temperature, because it is just going to scale faster. If you've got that higher temperature, they want erode faster, and they want that velocity to be lower if it's a really high temperature, and they define that as 140.
Yeah, so, and they're defining it on the recirc line specifically at 2 feet per second, because obviously it's your smallest pipe. So if you're 2 feet per second on your smallest pipe, you're going to be below that everywhere else. So if you look in Uponor's design manual, it does actually say that if you want to do 24/7 recirc at 140 degrees, you need to be under 2 feet per second. The numbers you were talking about, Max, that are the 1, 3, and 5, is by code. The 3 is saying that you need either a Honeywell or an Aquastat, an Aquastat or a timer to stop the flow at some point during the day. But if you ever have PEX with a 1, you have to have an Aquastat and a timer. They want double protection on the 1. So we had another one come through for pressure independent valves. Inlet pressure functions, but the outlet flow remains constant like a regulator. Have we talked about the pressure independent ones yet?
Yeah, so that would be this one here.
Oh,
so
we are. We're talking about right
independent of what the pressure is incoming, it's going to keep the same flow rate out. So that's
instead of having your pump be a ECM that can have a fixed discharge pressure, you're talking about a valve that doesn't care. And I don't know how familiar people are with the balancing aspect, what they have to actually go through. But if you don't have a ECM or a variable speed style pump, it's an iterative process, because the more valves you open, the more flow you have, which causes a change in pressure. So you balance it and then have to go back and rebalance and then go back and check the other ones. So that's the huge difference with your pressure independent ones.
Yep. Okay, then
here's the question for you.
Yep.
Are your balancing valves NSF 61 listed?
Yeah, so all the valves that I'm talking about on the slides will be rated for plumbing applications. And then we can send if you need documentation of that, we can send the NSF 61 listing on the spec sheets for these. Okay. The next style of balancing valves, which is kind of my favorite for DHW recirc applications, is going to be a thermal or thermostatic balancing valve. So if you're familiar with like the inside of a thermostatic mixing valve, there's a little wax cartridge that, as it heats up and cools down.
I have a hand up. Hey, Matt, you still have your hand up, so I'm going to click on allow to talk, but you don't have to say anything if I didn't notice your hand was up. Sorry about that. So you can unmute yourself now, Matt, if you want to actually ask something out loud. I think you'll be the first person. Please do it. people are usually too shy to talk out loud. Nope, maybe it was because yes, I don't think Matt had specifically asked me a question. Okay, so I'm gonna ignore the hand up for right now. I'm gonna lower your hand. If he puts his hand back up, I'll unmute him.
Okay. So the guts of this balancing valve is this, this little thermal actuator basically. So it's going to change the length, the stroke, depending on the temperature. So what that does is it's going to push the orifice up and down based on temperature. So everything that we've talked about so far has been based on flow. And then this is one of the competitors in this space, the thermosetter competitor, the circuit solver. So they have the same kind of wax actuator inside there that as the temperature changes, it's going to open and close the orifice. So ours, this is the compact version that you would use if you weren't going to use thermal disinfection, and that's going to be the inside of it right there. And then you can get it with the stem extension, isolation valves, check valve, temperature gauge. So you could just look up if it's, in the hallway of a hotel and see, is that supposed to be at 120 degrees? And it is. So that's helpful for commissioning as well. And then, so the valve is going to, as the temperature changes, it's going to change the CV of the valve. So let's say that you're starting up the building, you just swapped out all the water heaters, the building is completely cold, all the risers are cold, you turn on the system, all of those valves are going to be all the way open. So in this case, the CV is 2.1. And then as the temperature entering the valve increases, it's going to slowly shut it down. And then if the valve's set to 130 degrees, when you hit that 130 degrees, it's at its minimum CV of 0.23. So these valves don't close completely for a couple different reasons. One, we don't want to deadhead the pump. This is going to be the type of balancing valve you would want to use with an ECM pump because it is going to modulate the orifice. So you wouldn't want it to be fixed speed pump because you could get to, you could really limit the pump and get to a near deadhead situation. So that's why it's always open a crack. The other reason is that we want to allow a little bit of water to pass through there so we know when it's cooled. So if we said it's up to 130 degrees, close it tight like a drum, you wouldn't know that the recirculator had started to drop in temperature and that it needs to open up again. So it leaves it open at 0.23 CV. Then if it sees that there's a big demand on the building, the riser temperature starting to drop, it's going to open up towards that maximum of a 2.1 CV. So the CV is always changing, which is why it's a great fit for an ECM pump set to like a fixed pressure to just figure out what your pressure is for the system and have that kind of be flatlined. And then the flow rate could be all over the place. It's just going to maintain the temperature at the riser for each of those. So there's a question about tepid water for 100 degrees Fahrenheit. So our competitor in this space has advertised using these for cold balancing, that it's almost like it's installed backwards in a sense, because what it's trying to do is have flow go through to make sure that it doesn't get to that Legionella growth range, which I'll talk about in a couple slides, and stay there. So it wants to make sure that water isn't in kind of the danger zone between room temperature and 100 degrees. It's something that is I'm not quite sure how that works in reality. I think that the intent is good. We haven't had that many cases where we've thought we should also do cold water balancing. It really is a system complexity kind of jump, and maybe not as much benefit for the complexity there. But that's kind of how you could use it for tepid water. So the minimum, there's not really a minimum flow rate. We'd have the chart that we could pull up that you could see for each of the valves. But it really varies the CV. As long as there's some movement through there, that valve with like 0.0001 GPM would actually adjust based on temperature. So if it was at 130 degrees and then the power went out, that valve would open all the way up to the maximum CV in that case, even with minimal flow or no flow really. So, okay, then, so to elaborate on why the ECM pump, if you had, if you generally would design a balancing valve with a fixed CV, that is going to vary, and it's going to vary based on the temperature per riser. So you would have to have a pump, a fixed speed pump that is okay with all of those. Again, we'll just say it's 8 valves having a CV of 0.23, and also all of those valves having a CV of 2.1. That's going to be a pretty hard curve to find, where an ECM pump could just say, we're going to keep a steady pressure, and the GPM could be, 1, or it could be 10. We're going to keep that same pressure as a good way to set up those systems, and as a good complement to that style of valve.
Well, ECM isn't variable speed, so they're not confused.
Okay, yeah, and it could be a VFD, it could be some other variable speed as well. You could size for that. The ECM just seems to be the kind of prevailing technology along those lines, and maybe something that in the near future that they just say ECM is the only technology we're allowing to manufacture, like they have done in Europe. So that's part of the reason that the price of those ECM pumps has gone down, is that Europe has basically banned fixed speed pumps the same way that they've banned incandescent light bulbs. They say that you need to be able to vary this flow with a much more efficient wire-to-wire technology than a fixed speed pump that's being basically like throttled back down by balancing valves is just not a good use of energy.
Let's see if I can actually say it right. So ECM, just in case anyone's wondering, is electronically commutated
yeah.
motor. So variable frequency drive is the same kind of thing. It's just a way to control the speed of the pump. So two different terms that pretty much mean the same thing.
Then it gets too far into the electrical engineering side of it for me, but you would use a VFD with a permanent split capacitor technology circulator. And then it's really a frequency change. It's not we're actually like modulating like a gas pedal, an ECM pump, where you can only really variably speed a PSC pump to 50% or something like that. It's not like an ECM pump that can go down to basically barely moving any water up to full flow. It's just chopping it to kind of half performance of that pump, but it could still be oversized at 50%.
So I got someone with their hand up. So you should be able to unmute yourself. I don't want to say someone's name wrong. So go right ahead and ask a question if you got one. Saw you unmuted yourself.
Microphone's open.
May not be connected microphone wise.
Or you can type it into the chat.
Can you hear me?
Oh, there we go. Yep.
Okay. Hi, this is Ling Yan Gorsuch. I would say I disagree with the energy code that once the hot water reach certain temperature, you should stop the circulation pump. Yes, there's quite a bit of debate on this topic. So the energy code said, once you reach the temperature, you should stop. From water quality management point of view, it should be constantly mechanical circulation.
Yeah, that's a great point.
That's why I'm asking, what's your minimum flow? Because even if you reach the temperature desired, a lot of system distribute at 120 degree or even lower. That's still pathogen growth range. It's not appropriate to stop.
No, that's a great point. And one of the things that's confusing in this space with should we turn the recirc pump on or off, is that I think OSHA is one of the people now saying, like, don't turn it off. That's like a Legionella bomb. If you turn it off, we want that water moving and chlorinated all the time. So I think that the best that I can navigate all these different codes that seem to be going in different directions for Legionella growth versus energy savings versus water savings, it's hard to find like a middle point there. But the best way that I can think to do it is just to have the absolutely laziest recirc constant flow system that you can. And so we don't need 2 GPM screaming through all these risers all the time, but we do want to make sure that we've got a constant temperature. So that may mean that if this riser is warm, we set it to 130, that's all the way down. This riser is cold, or for some reason the insulation is missing on this whole riser, that may be near open all the time, but we have flow through all of the system all of the time. And then the ECM pump is so efficient that that's okay. It's not like we're wasting a ton of energy and be just like a small light bulb on, to have that smart pump just moving. It may even be ounces per hour if the whole building is warm, but we keep constant flow, which is important for the modulation of these valves. If you turn the pump completely off with an aquastat, we now can't modulate these risers properly. And then we're keeping chlorinated water going through as much of the recirc loop as possible, which is important for the pathogen side of it. So yeah, it's kind of difficult to navigate, but that's a really good point with that.
I'll say for us in, when we're helping with systems and stuff, because those two codes fight with each other, and it seems that it's going to become more and more prevalent that they do want the flow to continue because of the pathogen side. A lot of times in new construction, we'll go with that 127 pressure independent valve, size it based off the riser requirements, and put an ECM pump in just so that you can kind of trim it to what it needs to actually be, and you're not wasting energy, the VFD pump. The other way we'll go is the thermosetters we actually use quite a bit in retrofit when the building has no idea, they don't have plans anymore. There's nothing and they have no idea how to size the recirc systems, and we don't want them damaging the piping. So a lot of times on retrofit, we will use the thermosetters just because it makes it easy to not oversize a pump and then damage your system. So that's kind of where we sit on that right now.
Yeah, and one of the things that this picture is probably a good way to explain that too is if this is a new system and you know that the mechanical contractor is going to install it exactly like this with this exact amount of fittings and everything's going to be perfectly insulated and it's just a mirror of your drawings in the real world, you could do flow based with these. So you could do the cartridges and just say, okay, this is a 1 GPM riser, 1 GPM, 1 GPM, and that will work fine. It's in the cases where, we had to jog around, 10 other trades that were in this chase. So there are like 40 more 90s on this riser now. And also they forgot to insulate riser number 2, or the insulation was taken off of it because somebody put a picture on the wall and put a hole through it and they never replaced the insulation. In that case, these valves are just going to fix it. They just adjust open and close to fix it, where if that were enough to throw off your sizing with a flow-based balancing valve, you'd have to replace the cartridge, where you wouldn't even know with the thermal balancing valves because they're just going to fix it. They're just going to be open more to accommodate for that heat loss, or more fittings and more pressure drop through there, whatever the case may be. So retrofits are one of our favorites. We had a hotel in New Jersey. They won't ever let me use the name of the hotel because of, they want that for legal reasons. They don't want to be associated with, anything in a trade magazine related to, how they're, addressing Legionella or things like that. But there was a building that was like a 14-story hotel that they had the penthouse, suite in this hotel. They really couldn't rent because it would take like 45 minutes to get hot water to that top, most hydraulically remote set of fixtures in the building. And they went back in and put thermosetters on all the risers, and within the hour it had sorted itself out, and they could have people stay in that penthouse again because they could get hot water there. They were forcing it up to that path of most resistance, which was that particular unit, which was something that just every single time they had a person go stay in that room, as soon as they tried to take a shower, they would be calling down to the front desk to say, we can't get hot water here. So that, regardless of what happened behind the wall over 10 different property managers that you don't even have anything close to an as-built, you were able to just sort that out with the thermosetter, and that's a great application for it too. Okay, I'm going to go through, and I've talked about this a little bit before, how to balance these actual valves. So this quick setter, you're just going to take a wrench, and this guy's pulling the pin at the same time, adjust the flow rate there. A manual balancing valve like the flow set that we show here, you have to make sure that you've got the right chart for that valve. So it's going to be based on the valve size and for that unit. So it's not like you can carry around one chart for the day and be set. So a little, potentially more opportunity for error on the commissioning side there. But again, possible.
The biggest issue I see with this is on the contractor level, just not used to looking at this style of graph. and not realizing it's a log graph.
Yeah.
So when you're using this, just if you see these where the lines are not separated equally, your halfway point is not your halfway point.
Yeah.
And that can make a big difference on a bigger valve. So
Yeah.
that's the only issue I see with these, is sometimes reading
Yeah.
these.
And again, people that do this all day, every day, they wouldn't need my help to do it, but it
Yeah.
is a little bit more complicated to get that right. So again, this is the procedure for the Quick Setter Plus, and that's what the gauge looks like from the front for a hot water application. You know, the graph is going to be half to 1.75 in this particular size, where hydronics for that same size with a different velocity, feet per second, would have a different scale there. So hydronics versus the plumbing will have a different measurement. Then this comes up sometimes, is that some people want the ability to be able to adjust the thermosetter temperature at any time, to just say, you know what, if we can't get this riser balanced, we want to be able to just go and turn it from 120 to 125 and sort it out. Some other places say we do not want anybody touching these balancing valves. So what you can do is you can just take the screw out of the top, put the cap back on so it straddles this little piece on the cap, and then put the screw back in, and that locks it. So we've done that before too, where before it's even installed, people will just, you know, on the tool bench or whatever, will set the temperature, lock it, put it together, and then when it's installed, you'd have to take it apart, take the cap off to be able to change the temperature. Depends on what you're looking for there. Sometimes that's helpful, sometimes it's the wrong direction, kind of depends on the use. So adding additional circuits, you have to rebalance with the manual. Just it keeps working as it was before with the thermal, and then same thing with a manual with a variable orifice like that. So this would be an example of probably most buildings, most commercial buildings that were either never balanced, were never verified that they were balanced, or were balanced poorly, is that this first riser has no problem. This least, most hydraulically remote fixture right here, it has, you know, physics are against you there. It does not want to get hot water up there. This pump is going to try and get the easiest way back to the mechanical room. So that's where we're kind of sorting that out, either with flow or temperature-based solutions. So I'll cover a couple projects here, and then I'm going to leave some time for the Osborne guys if they want to mention something specific. So I'm going to skip to, because we already talked about a project like this. I'm going to skip to, this is a high school retrofit in Massachusetts called the Mashpee High School. So they wanted the ability to do thermal disinfection. So they used our thermosetter with this additional valve body. You can kind of see this additional chamber here. And we have two different options with this. We can add an actuator. So you're actually toggling thermal disinfection with a 24 volt signal, or we have thermal cartridges that you put in there that once you get to 160 degrees, that's now coming out of this Legio mix. If this goes into thermal disinfection mode, it's going to say, normally I'm doing 120 degree outlet. For the next half an hour, I'm doing 150 degree outlet temperature. So the first chamber of this thermosetter is going to say, okay, that's too hot, I'm going to close down. That's kind of the normal operation that I've talked about with the valve so far. There's a second chamber here that's going to say, okay, we are now at 160 degrees, open. So then this chamber is going to let that thermal disinfection hot water through, and it can be either toggled again with a 24 volt signal, or with just a wax actuator that's made to open at the high temperature. And then when it cools back down to 150 degrees again, it closes and it goes back into normal operation with whatever you set on the dial. Two different ways to do the same thing. We also sell this in, you know, the larger sizes. It just comes like this with a cap there. I like to call that kind of thermal disinfection ready. So if at some point you install this Legio mixing valve and these thermosetters with a blank basically in it, that would be thermal disinfection ready. So then in 2 years, they say, we want to manage Legionella with thermal disinfection. We could say, great, just change this valve from program 1 to program 4, set your disinfection temperature and time, and then drop in a cartridge to each of these valves. You wouldn't need to run wires if they were all remote. That's where the thermal cartridges are a good fit. Just throw in the cartridge to 150 degrees or 40 degrees or whatever your temperature is, And then it's going to be, thermal disinfection through all of those risers at the temperature that you set out for. So that's what they did here. It was a tricky building because it was an existing building. They installed I think there were 3 Legion-Mix valves on this project because there's like a middle school, high school, and like a lab, like a science lab that all had their own mixing stations. And I think it was in the middle school, they said, hey, no one ever insulated that recirc line. We set this to disinfect at 140 degrees for a half an hour, and we cannot get that water back hot enough. So what we were able to do is just change the temperature and say, okay, why don't we target 150 degrees for 15 minutes or whatever it works out to be on that Legionella disinfection chart. And we were able to just up the temperature and lower the amount of time and do thermal disinfection that way too, instead of having to repipe, or best cases they would just insulate. But if they can't get to it because it's under the school or something like that, we were able to make modifications with just the program here. And then you could even, in some cases, if you had to put in a different cartridge, warmer temperature cartridge in one of these thermosetters, you could do that too. So that's kind of one of my favorite thermal disinfection projects that, normal circumstances, it's just an ECM pump sending the minimal amount of hot water to all those different parts of the building, which is great because occupancy is all over the place for a school, that they may have a bunch of people in for a basketball game and then nobody's there Saturday and Sunday. So it lets it be the laziest version of the recirc system on a Saturday when it's in thermal disinfection mode for that half an hour or that 15 minutes or whatever. It kind of brings a different part of it to life automatically. So the installing or the service person, the property manager, doesn't have to do anything. It's just going to thermally disinfects anything that's in the recirculated loop automatically once a day on Saturday at 2 in the morning or something like that. So those are the different valve styles of that quick setter. So the basic one, I think, is like a 116.4, I think is what we call it in our product nomenclature. It's just going to be this thermal balancing valve. And then the 1 and the 2 and the 3 are different versions of what's in this second chamber, a blank, a thermostatic cartridge, or something that accepts a 24-volt actuator. So that's kind of how you could really just modern thermal disinfection ready or thermal disinfection capable system with a thermal balancing valve, where with your other balancing valves that are flow based, they're going to they're going to respond to flow, not temperature. So it's a different kind of type of calculation you'd have to do thermal disinfection through those systems. So one of the questions, what are the dimensions? Will this fit into a framed wall? So I'd have to look at the full assembly if you had the check valve, the thermosetter, and then the isolation valves to see what that would be. We do have that in the technical brochure that I could either.
And you would also rotate it to the flat side.
So
as long as it's not over 6 inches, it can be in that side direction if it needed to be rotated, so it doesn't have to stick out.
So this one is rotated a little bit.
With the actuator and stuff, I'm positive without the actuator or the bypass, because even though the bypass cartridge isn't going to stick out that much, I think it would just be dependent on the size of the actuator that's used.
Yeah, so that would definitely be sideways in the wall, and that would be pretty wide. That would be 6 inches tall or something like that. So probably wouldn't fit vertically in a 2x6, but you could turn it. And then there's that. Did you want to mention any of the projects that you guys have worked on for any of the balancing valves that we've talked about that are kind of specific to the market out there?
Yeah, so one thing I want to say, just in case we lose them, anyone that asked a question, thank you very much for asking questions. It always makes it better that we can get you the information you need. I do want to say to Ling Yang, thank you very much for actually talking out loud. It doesn't happen very often, so we always really appreciate when that happens. Also with an access panel for in-wall access, it would kind of depend on which access panel you're using. You know what I mean? We'd have to see the because you guys aren't going to offer the access panel, so it's like how much room is the access panel taking up, or the holder, not just the panel door, obviously, but how much is
Yeah.
that whole assembly going to take up? I have a feeling it would fit. Once you rotate it, right? You don't want it
Yeah.
sticking out like it is in the picture.
Yeah.
I know we are after 1, so I do want to thank everyone else that was here. So we're probably going to talk for a couple more minutes about random stuff. But if you have to go, you have to go. We all only have a certain amount of time for lunch, and we do appreciate having you all here. So thank you very much for those that came in. One thing I was going to mention, just to make some people's lives a little bit easier, we did have a hot water recirc system, and it wasn't really a balancing problem, but it looked like a balancing issue because they were getting elevated hot water temperature back, but they weren't getting hot enough water back. And so they were very concerned that the balancing wasn't correct. They were very concerned that there was crossover somewhere. So I actually did a site inspection for them, and I immediately knew what it was. They had undersized their pump, which is very rare. It's usually an oversize issue, but they had undersized their pump. And these poor plumbers had spent 2 weeks trying to figure out where their balancing issue was because, it was engineered for that pump. And what it ended up being was the pump just wasn't big enough. They needed 12 GPM. The pump they had picked couldn't even do 12 GPM. And I brought in an ultrasonic flow meter just so we could test it for them, get an accurate read. And they were only getting 3 GPM. So it's like, this is one of those situations where what I want is more flow, but what that means is I need more head, because you won't get more flow without more head. But what could have saved them, they said they spent 2 weeks on this. What could have saved them a lot of time, and it's very easy, and it's actually nice to have even in the future, is if they had just put a pressure gauge or at least a tap port before and after the pump. So on the inlet and discharge of the pump, it was a fixed speed pump. You can do this with a VFD pump if you need to. You just have to know what speed it's running at or set it to a constant speed when you're testing it. But the differential pressure across the pump will tell you what the flow is, just like a differential pressure across any valve will tell you what the flow is. So they could have confirmed for themselves by just adding pressure taps at the pump. But they had circuit setters. The problem is they couldn't use their circuit setters to calculate the flow because they weren't getting enough flow. So it looked like there was no flow. So sometimes it is beneficial to have those pressure ports somewhere close to the pump. That was my 2 cents on that one. But
yeah, and then you mentioned cross connections. That's another thing that is going to make balancing really tricky, and just hot water to all the fixtures very tricky. Is there are some shower valves that allow a cross connection to happen right there. So if the detective work piece of finding a cross connection is to find out, is this riser cold? Just the units on the second, third, fourth, fifth, sixth, all the way up, they're all cold. Everything vertical of this one spot is cold. It could be a cross connection right here. That's only allowing the hot water path of least resistance is just going to come right back there through the cross connection. So you're not sending any hot water up here. You could balance that with any valve that we've talked about, and it's not going to fix the cross connection there because it doesn't, the water's not doing the full loop. If you say, okay, everybody on the 7th floor has issues with hot water, that's a different thing. That might be just none of these risers have enough flow all the way to the top floor. So it's kind of, where are your balancing issues by unit? And you look at that on the building and say, everything on this riser above this is bad. That could be a cross connection at a shower valve or something like that. If it's everything in the entire building is bad, the next thing to look for is one of those just like 2-handle mop sinks in the maintenance room, because you probably have a cross connection right here. So you're going to, you're basically not recircing to any of the building. And that's what we found in some cases too, where we just could not get a building to balance out right. And it was because we had a cross connection that was 8 feet away from the mixing valve and the recirc pump in a mop sink or something like that. Those are kind of notorious for having a cross connection potential without check valves there.
And another thing too, when we start talking about crossover in a non-occupied new building, if you're really worried that there's crossover, it is easy to check because your cold water should not be coming back hot. So
Yeah.
if you have no demand and your cold water is actually at an elevated temperature,
You're in
then you
trouble.
have
Yeah.
crossover somewhere. And
Yeah.
I've seen that before. I think the hardest one for me to diagnose, and because it's really weird, and it is a system issue, not necessarily a balancing issue, is you got to remember that you cannot push water into a higher pressure zone. So I have had hot water research systems where their return line, where it tees in, the water on that actually has higher pressure than the return water line. So if you
Yeah.
have lower pressure on your return water line, you cannot push water, obviously. So you end up with a whole loop that can't get circulation. But that one
Yeah.
is really hard to diagnose, and it's a little bit weird. You
And
don't
that
have
one's
valve
tricky, that in some cases, if it's multi-story with different pressure zones, that you can't really recirc across a pressure reducing valve. So
sorry, Charles. Charles put in a question, and I was laughing
Okay.
on that one. And the only reason I was laughing is that's how new their lead-free
we need
plumb
that.
vent is. I'm assuming this picture came out of one of the hydronics that you guys had issued.
Yeah.
Yeah. How long has the plumb vent been out? It's only like 2 or 3 years, right?
Yeah, if that. And so it's
Yeah.
to the catalog, but yeah, that would be a good spot to put it. And it's something that there's a little bit of convincing that we need to do as a manufacturer, because if we talk about it in the marketing sense, there aren't 10 other competitors for plumb vents, which either
So getting
means
it
that
specified is
so it either means that the problem doesn't exist and we're crazy, or there just hasn't been enough time to to kind of show the problems that it can solve. And we think that there are just more opportunities to solve problems where we've got big air pockets and risers, and just have some more marketing work to do.
The only thing I'll say about can you guys still hear me? I think
Yep.
Okay, my headphones changed. One thing I'll say, and then I will kind of move on and say goodbye to Max, is the plumb vents where we have actually used them is in the Legio mixes. We end up with a lot of commercial projects that have multiple Legio mixes, and I guess I should undo my video for this. What will end up happening is you end up with a U, right? And you have one mixing valve at the top, and then one more, and then up to maybe even a third mixing valve, but they plummet up in a U. We've actually got an airlock on either side of the mixing valve on the hot and the cold inlet. So we'll have them put air vents at the very top of those just to make sure it purges out any air. So you can actually create high point zone issues in a domestic. We do use them. That's one of the weirder applications where people don't think to put it.
And one to look for too is if you had a whatever your recirc pump is, that was if you've lost a couple of those and they were over temperature, that like a hydronic system, if there was a bunch of air that somehow was in that recirc pump housing and it wasn't able to lubricate itself and keep the temperature low, that would be the scenario where you'd say maybe a plumb vent would be a good fit somewhere here to catch that air pocket before it gets back to the recirc pump. Definitely an outlier, but potential. Oh, I think you're muted. Oh, we can't hear you, Brian. There we go.
Hi, can you guys hear me?
Yeah, I can hear you.
Question on those air vents, do they allow for any moisture to come out?
So one of the things that I would recommend is we have this cap that you can put on an air vent that has, if that's a concern, if you say that like no water can ever come out of this because it's the top of the riser and we can't even have a drip of water come down the side of the valve, we have this cap that you can put on an air vent that has fiber washers in it, and when water hits it, it swells and it seals, so then it wouldn't be able to vent any air until it dried, and then it would vent air again, but it doesn't let water come out. So that would
okay.
be
Well, my question
Yeah.
more was about like the moist air, kind of like a humidified air that's released, and being that it would be in a wall, probably, right, or up in an attic space, that at the highest point of that riser would over time, because it's releasing moist air, allow for mold or anything to grow.
Yeah, I mean that would be something that depending on how much, if that is tight as a drum, that could be a concern, and probably be something that you would want to avoid. If it's a mechanical chase, that there's some airflow through, or if it's in a plenum or something where there's air that's moving across a commercial space for all the returns up there, I wouldn't worry about it. But yeah, that's a good point, that if for some reason the top of this riser was in a pretty, sealed chamber, that might not be a good spot for it. And
Okay.
again, I mean, it's not going to be like, hopefully, if there is that much air in the system, that's an
Yeah,
issue.
that's a bigger problem,
yeah,
right?
Yeah, it shouldn't be doing it so often that you're getting,
Yeah.
Florida humidity behind your wall. So
Got it. Okay, thank you.
okay, so got that one in. Thank you, Andy, for speaking up. It's always appreciated. So thank you guys for attending. I know we ran over. Lin Ying, I'll get those sent over to you for the different balancing valves. I'll get you sent over because I have your contact information from registering. So I'll get you the balancing valves and plumb vent cut sheets that show the listing for you. So we'll get that sent over to you. So thank you everyone for attending, and you'll just look for another invite. We'll have another one coming up. I think we have a little bit of a delay, so it'll be about 4 weeks before we have our next one. But thank you again, Max, for coming. Always appreciate it.
Yeah, thank you.
Yeah, so you guys enjoy your afternoon. Thank you very much.
All right, thanks everybody.